Here's what these liabilities are to you and me outstanding right now. $21 billion. Now what kind of regulator allows those kind of liabilities to grow year after year after year with no change? And here's the liability management rating. Just look at the bottom there where they talk about deemed total estimated liabilities. That's where the 21 billion comes from. But here are their security deposits for cleaning up this mess. $87 million. Now remember where I talked about loss of statecraft in this province? Where you've got people in government who can't even do basic math, who can't figure out that $87 million is not much of a security on liabilities totaling $21 billion. And so, my question is, did Bill McCrank ever actually work for us in that whole period? The revolving door again, who replaced him? Well, here's our new chair, Dan McFadden. And where did Dan McFadden come from? Well, Dan McFadden was Vice President, Regulatory Affairs and Public Policy, Canadian Energy Pipeline Association. Now, we've often caught members of the ERCB in bed with oil and gas companies, quite literally. Here was a case a couple of years ago where there was a hearing down in the eastern slopes involving sour gas wells, where a member of the board was actually sleeping with, I believe it was a member of Petrochem. Now what about the performance of this board? Well, this is a really wacky board. This board, since 1998, has approved more than 100 oil and gas projects. All right, it had a staff of 20 in 2003 in Fort McMurray. 2008, that staff increased by 40. How the hell are you going to manage 100 mining and in-situ projects with a staff of 40 people? And was approving 100 projects in that time frame in the interests of Albertans, given the volatility of oil prices? Here's another issue of phenomenal importance to all Albertans, and this is the growing gap between inactive wells and abandoned wells and on the landscape. And we've gone from something like 20,000 wells nearly 25 years ago now to more than 60,000 inactive wells in this province that have not been abandoned, have not been reclaimed. These are enormous liabilities on the landscape. Here's what these liabilities are to you and me outstanding right now. $21 billion. Now what kind of regulator allows those kind of liabilities to grow year after year after year with no change? And here's the liability management rating. Just look at the bottom there where they talk about deemed total estimated liabilities. That's where the 21 billion comes from. But here are their security deposits for cleaning up this mess. $87 million. Now remember where I talked about loss of statecraft in this province? Where you've got people in government who can't even do basic math, who can't figure out that $87 million is not much of a security on liabilities totaling $21 billion. That's probably the guy that designed that program. The other thing about the ERCB is their dishonesty. If you look at their reports, and I just picked out one example. Here and this is from a 2010 report, and they're talking about public complaints and complaint issues. And they're saying, look, isn't this great? The number of complaints is going down, and you know what? It probably is due to the fact that our oil and gas companies in this province are fine, fine citizens. And that's what they say. That's complete bullshit. The complaints went down because the level of drilling went down. It had nothing to do with the performance of oil and gas companies in this province. And that's the kind of stuff the ERCB pulls all the time. All right. What the frack? Now, I thought maybe I could start with Frackosaurus, my friendly buddy here. I kid you not, this is a program that Talisman put together and wanted to put in the schools in the United States to help kids have warm and fuzzy feelings about hydraulic fracking around the schoolyard. Frackosaurus. I'm here to teach you about a clean energy source called natural gas, found right here in the Twin Tiers. Well, as you all know, there has been a phenomenal revolution in natural gas production on the continent that has resulted in the growth of reserves for natural gas, and the technology that has been used to produce this glut of natural gas is now being turned on shale formations containing oil, light oil as well. And it is a revolution in the sense of the pace, the scale, the volume of materials, the sheer number of people impacted, and the extraordinary land base here. Just take a look at this. I mean, look at the land base here that is being affected by these developments. You know, we're talking about millions and millions of people being affected by this. And then the industry and regulators are kind of scratching their head and wondering, well, why are people getting so exercised about this? Well, all you have to do is look at a map. So what is this? Well, here, you know, here's shale rock. Unfortunately, it just happens to be the most common rock on the planet. It's about, you know, has about the density of concrete, and we're talking about formations that are, you know, 1,000, 2,000 feet below ground, and the object is to shatter this rock to produce the gas or oil that might be contained in it. Now, each one of these formations is different. It comes with different characteristics as well as different production rates. This is from the shale from Horn River Play in British Columbia, where, okay, so you frack the hell out of this formation. You're only recovering 20% of the resource. Only 20%. That's a small return. You are looking for hydrocarbons in pore spaces that are 1,000 times smaller than conventional oil and gas. All right, you're looking for sardines here. This formation contains radioactive particles, as do many of these deep formations. Many of them also contain arsenic and mercury. This one also is rich in hydrogen sulfide. There is saline water in this formation that will also be produced. And then you have an incredibly high CO2 content. Normal natural gas has a carbon dioxide content of 2 to 4%. Horn River has a content of 12%. So you cannot use that gas until you take out that CO2. Where's that CO2 going to go? Now, here's just an illustration of we've got two technologies that use here. One is horizontal drilling, formerly known as slant drilling, a practice that was invented in East Texas and California in the 1920s and 1930s when you wanted to steal oil from your neighbor. That's what the oil companies did. So they invented this drill bit that helped slant the drill, and you could go and drill underneath someone else's property and steal that oil out from under them before they had completed draining it themselves. And then you had something called hot oil. And so that's where horizontal drilling started. And then in comes the hydraulic fracking, which is you're taking an explosive charge and you're letting it off underground to fracture this shale rock, and then you're sending down proppants and sand and water at incredibly high pressures to break it open and free either the gas or the oil. So in some parts of British Columbia, you're using 100 to 300 tons of sand on frac. In Canada is shipping this sand in from Saskatchewan all the way to northern British Columbia, believe it or not, by truck. And then you've got the proppants, and the proppants, sometimes the proppants are sand, and sometimes they're ceramic beads, and sometimes they're husks of walnut shells, and whatever, rubber bits, you name it, whatever they think might work down there. You've got to remember that hydraulic fracking is pretty much a science experiment, and it's much more chaotic than Julia Child in the kitchen.